This question gives us just the weights or the forces of gravity of two different masses on a pulley system with an inextensible string or rope connecting them. And we have a frictionless surface, and we're asked to find the net acceleration. In other words, find the acceleration of the system. With these pulley systems and inextensible cables, the convention that we use to define what is a positive and negative direction is really just always in the direction of motion of the cable. So if this is defined as positive, even though the cable is moving through the pulley changing direction, it's still moving together as one, and so that movement through the cable be always in the same direction. That's a little bit hard to get a grasp of. For example, if we had a cable that was looping around itself, maybe doing all sorts of twists and turns, as long as it was being pulled in one direction, that means everywhere in that direction of motion would be considered positive. So you can see how many different directions it's going in. It's going left, right, up, down at different points. But at all of these points, it would be in the positive direction. And therefore, everything moving in the opposite direction is negative. So let's start by coming up with a net force equation, F net. And to do that, we'll do a free body diagram at each point. So we have the force due to gravity of this mass and the force due to gravity of this mass. We also have a normal force on the mass on the frictionless table, and there's actually no normal force of the suspended mass. However, there's a tension, force due to tension, which is the same magnitude as the block on the table. So we're going to see that the normal force cancels with the force due to gravity on the table, because this weight is not moving up or down, it's only moving to the right. Just looking at this, we have the force due to gravity pulling the system down. That's providing 100% of the acceleration of the system. There's no force of friction or anything pulling back. The force of tension is just what's transferring the force through the cable. It's moving the system together. So the net force is really just due to the force of gravity of the 10 Newton weight. The force due to gravity is mass times gravity. However, this is given in newtons, which is a force. Number are the units for force. So we actually have that already. Now on the left side, what do we write for the net force? We use Newton's second law. The mass times acceleration equals the force. Now net force always uses the total mass and the acceleration of the whole system. Acceleration of the system is what we're solving for. And so let's substitute for the total mass, which we cross divide. So what is the total mass? Notice we're not given masses. The units for mass are kilograms. These are newtons. So how do we convert from a weight? Remember, weight is the force equals mass times gravity. Therefore, the mass equals the weight or the force divided by gravity. So we're going to divide 50 newtons and 10 newtons by gravity in order to convert it to the mass. So the total mass is the weight of the one mass divided by gravity. We use 9.8 plus the weight of the other divided by gravity. Simplifying this, we get 10 divided by 6.12, which equals 1.63 meters per second squared.